Today I'm going to discuss 2017 paper 2 14 question part B. So now I'll read the question. In the figure, ABCD is a rectangle with AB 1 meter and BC root 3 meters and CD is an equilateral triangle. Forces of magnitude 5, 2 root 3, 3, 4 root 3, P and Q newtons act along BA, DA, DC, CB, CE and DE respectively in the direction indicated by the order of the letters. This system of forces reduces to a couple. Show that P equals 4 and Q equals 8 and find the moment of this couple. Now, the direction of the forces acting along BA and DA are reversed, but their magnitudes remain the same. Show that the new system reduces to a single resultant force of magnitude 2 root 37 newtons. Show further that the distance from A to the point at which the line of action of the resultant force meets BA produced is 7 over 4 meters. 3. So I have drawn the diagram they have given. In the figure, ABCD is a rectangle with AB 1 meter, BC root 3 meters and CD is an equilateral triangle. So if CDE is an equilateral triangle, all the sides should be equal and the angle should be 60 degrees. We have to mark all the details they have given in the question. Forces of magnitude 5 act along BA. So we mark that also. 5 newtons act along BA. 2 root 3 newtons act along BA. 2 root 3 newtons act along BA. 3 newtons act along BC. 4 root 3 newtons act along CD. P act along CE. And Q newtons act along BE. In the directions indicated by the order of the letters. This system of forces reduces to a couple. So reduces to a couple means equivalent to a couple. Show that P equals 4 and Q equals 8. So to show that, first we have to use the vertical and the horizontal component for that. By using these two, we can get two equations, and by solving those two equations, we can get the values of P and Q. So first, I'll use the horizontal component. So for this, we can use 5 newtons. But the sign should be minus. Why? Because the direction is to the opposite side. Then we can take 3 newtons plus 3 because it goes to the same direction. Then we can take P and Q. So if you take P, it's P cos 60 because when you resolve P towards the angle, it's cos, and since the angle is 60 degrees, we take P cos 60. And it should be minus because it goes to the opposite side. Next we have Q. We resolve Q towards the angle, so it's cos, and since the angle is 60 degrees, it's Q cos 60 equals to 0. Plus sign because it acts around to the same direction. Now we have to simplify this. We get minus 2 minus P into cos 60 is, it's half, plus Q cos 60, it's half, then you write half again, equals 0. Then you can take this 2 to the other side. So it's Q over 2 minus P over 2 equals 2. I took Q front because it's easy because it's plus here. So now we have to take the common denominator. It's 2, so we write P over 2 equals 2. Then we have to remove this 2. So we multiply both sides by 2. So this will get cancelled. Q minus P equals 4. That's the first equation we get. Next, we find by using that, we can get 2 root 3. But it should be minus because it acted on to the opposite direction. We can take this 4 root 3. It's also acting along the opposite direction, so it should be minus. Then we can take P and Q. We have to resolve P away from the angle. So it's P sine 60. And it should be plus because it acted on the same direction. So it's P sine 60 plus Q. When you resolve away from the angle, it's Q sine 60. So it's Q sine 60 we write equals 0. Now we have to simplify this. So we get minus 6 root 3 plus P. What is sine 60? Sine 60 is root 3 over 2 plus Q root 3 over 2 equals 0. I take minus 6 root 3 to the other side. So it's P root 3 over 2 plus Q root 3 over 2 equals 6 root 3. Okay. So then I'll take root 3 over 2 out. So it's P plus Q equals 6 root 3. Okay. Then I can remove this root 3 over 2. Then I get P plus Q equals 6 root 3 to 2 over root 3. So when you cut root 3 to root 3, you get P plus Q equals 12, equation number 2. Next, we have to just solve those two equations. Then we can find the values for P and Q. Q minus P equals 4, first equation. Q plus P equals 12, second equation. So I can add these two. So when I add these two, you know it's 2Q equals 16, Q equals 8. We have showed one value. Next we have to show the value of P. We can substitute Q equals 8 for the first equation. So I'll write from equation 1 minus P equals 4, Q equals 8, minus P equals 4, P equals 4. Right? So the first part is done. Next we have to show, find the moment of this couple. Next we have to find the moment of this couple. So to find this moment, I am going to take moment D from D. Okay. So if I take moment D to the clockwise direction, I get this Newton. I can take this Newton. I can take this Newton. I can get this. But we can't use this, this and this Newtons. Why? Because it goes through D. So we are not taking those 3 Newtons. We only take 5 Newtons, 4 root 3 Newtons and P Newtons, right? So we can take 5. You know, moment is equals to force into perpendicular distance. So if we take 5, what is its perpendicular distance? Root 3 meters. So I write root 3 plus this is its needle 4 root 3 Newtons into its perpendicular distance is 1. And P, it's plus because it goes to the clockwise direction. Next we have P, and it should be minus by it goes to the anti-clockwise direction. So it's minus P. This force into its perpendicular distance. So this force is, you know, it's P sine 60. When you resolve it away from the angle, it's P sine 60 into its perpendicular distance. So it's P sine 60 into its perpendicular distance is 1 meter. Right? Then we have to just simplify this. So you get 9 root 3, and you know P is 4, so you can substitute 4 into sine 60, you know it's root 3 over 2. Then you can simplify this to this. Then you get 9 root 3 minus 2 root 3 is equals to 7 root 3 newtons. So this is the moment of this couple. We have done that part also. Next we have they have given another question here. Another different part. Now the directions of forces acting along BA and DA are reversed. Now the forces acting along BA and DA are reversed, which means it now goes to the opposite side. Now it should be 5 newtons. This should be upwards to the upwards direction 2 root 3 newtons. The reverse, but the magnitudes remain the same. The magnitude is not changed, only the direction is changed. Show that the new system reduces to a single resultant force of magnitude root 2 root 37 newtons. Now we have to show that the new system's resultant is 2 root 37 newtons. So to show that, we have to find the horizontal and vertical component. That means you have to find x and y and then find the result. Okay. So we can find it again. The horizontal direction is x. So we have 5. Now it's positive. Why? Because it goes to the same direction. Here we can take 3 newtons. Then we have P and Q. So P is minus because y goes towards the opposite direction. So it should be minus. So it's P cos 60 plus Q cos 60. Okay. So I'll simplify this. So you get 8 minus P. You know you have to substitute P. And you know P equals 4, Q equals 8. So you have to substitute that. 4 into cos 60 is half plus 8 cos 60. So this to this get cancelled. 2 times 1, 2 times 2, 2 times 1, 2 times 4. Get 8 minus 2 plus 4. So you get 10 newtons here. So x is equals to 10 newtons. Then we can find y component. We can take this Newton, and these two. So we can take 2 root 3 newtons, but it should be plus now. Why? Direction was changed or it was reversed. And this it's the same thing, so it's minus 4 root 3. Q, when it's resolved away from the angle, it's plus Q sine 60 plus P sine 60 away from the angle. We can simplify this. So it's minus 2 root 3 plus Q, you know, it's 8 root 3 over 2 plus 4 root 3 over 2. So you can simplify this. 2 times 1, 2 times 2 minus 2 root 3 plus 4 root 3 plus 2 root 3. You get 4 root 3 newtons. So y is equals to 4 root 3 newtons. Now you have got x component, y component. Now you just have to find the resultant force. So to find that, to find the resultant, it's x squared plus y squared whole thing root. So what is x squared now? N squared plus y is 4 root 3 newtons whole thing squared into square root. So it's 100 plus 4 squared is 16, root 3 into root 3 is 3. Then you can have 100 plus 48, and it's 148 squared. You can write 148 into 4 into 37 is 148. Then you can take the root of 4, so it's 2 root 37 newtons. So that part is also finished. So we have found the resultant force of the new system also. In case, even though they have not asked to find the value for theta, let's just find it. Tan theta is equals to, y over x. Okay. So y is 4 root 3 over x is 10. 2 times 2, 2 times 5. 2 root 3 over 5. So theta is equals to tan inverse 2 root 3 over 5. Done. Now it's the last part. Last part they have asked us to show further that the distance from A to the point at which the line of action of this resultant force meets BA produced is 7 or 4 meters. Right. Now we have to find that this distance, we have to show that this distance is 7 over 4 meters. That is what we have to show. So to show that, we have to, let's mark this distance as x because we don't know what the value is yet. So I can take moment from A by resultant. I can equalize this to moment of A by system. When we equalize this, we can get this distance. So by resultant means this one. So that means resultant is force into its perpendicular distance. So this force into its perpendicular distance. Right? So R, when it's resolved upwards, so that means when it's resolved away from the angle, it's R sine theta. We don't know this theta yet, no? So we know theta, but we write R sine theta. So I write R sine theta into this distance. We don't know it. So it's x. So we write x equals to moment of A by system means we can take this into its perpendicular distance and this into its perpendicular distance. Right? So 4 root 3 into its, what is its perpendicular distance? 1 plus this force into its perpendicular distance, that means it's 3 into its perpendicular distance is root 3 meters. It's plus because it goes towards a clockwise direction. So now you all might think, okay, we have to find this separately, we have to find R sine theta separately. No. We don't need to find that separately because this is the y component. What is the y component? Y component we have already found, it's 4 root 3 newtons, right? Y is 4 root 3 newtons. So you don't have to find this R sine theta separately. It's the y component, so we just substitute that because R sine theta is y, it's y component. So we can write 4 root 3 into x is equals to, now we have to simplify this, so you get 7 root 3. Get 7 root when you simplify. So we have to find x, so I divide this whole thing by 4 root 3, 4 root 3, then x is equals to, this get cancelled, 7 over 4 meters. So that's all. So we have found that the line, this distance is 7 over 4 meters. But the answer should not be finished from here. Okay, you have to write after this, after finding that x is equals to 7 over 4 meters, you have to write, therefore, line of action of force of resultant produced BA, this line is producing BA, produced BA is 7 over 4 meters, 7 over 4 meters away from it. From here, the answer is finished. So this